This episode of Hello PhD is sponsored by Promega and listeners like you. Thanks for your support.
I have all of the boxes and the tips that haven't been contaminated, and I can't find the recycling bin. Honestly, the look she gave me, I will never forget this look.
Of course we throw it all away and burn it. We're biologists.
Welcome to Hello PhD, a podcast for scientists and the people who love them. This week, we learn about some simple ways to make your research a little friendlier for the planet. Stay with us.
And we're back. This is Hello PhD, episode 108. I'm Joshua Hall.
And I'm Daniel Arneman.
And we'll discuss the human side of science and life in the lab. Hey, Dan, I'm feeling extra excited to be here in the studio tonight.
What is the occasion, Josh? You're not always equally excited to the maximum amount?
Well, we just got done with a great interview that was super cool. I'm so excited to share it with our listeners.
Oh, excellent. And I see we have something special sitting in front of us, too. You have a special beer today.
I did. Maybe that's why I'm excited, too, Dan. I am taking us back down memory lane tonight.
Yeah, this looks very familiar to me. Why is that?
Well, this is a beer that I would gather we have shared together many, many times through the years, including when we were in grad school.
Okay, so it looks like this is the Copper Line Amber Ale from the Carolina Brewery in Chapel Hill, North Carolina.
That's right. And Carolina Brewery was one of the staples for us when we were in grad school. And I think we've mentioned this before, but it's been a few years since we were graduate students, and there were not quite as many microbreweries back in those days as there are today.
That's true. I would have a hard time counting the number that there are now, and then it was 2 probably.
Yeah, there were 2. There was Top of the Hill, and then there was Carolina Brewery, both of which are still in existence today. But Dan, this was probably the first microbrew that I ever had.
Wow, this very
beer.
Wow.
Yeah, because Carolina Brewery was right there near campus. And, back in those days, but it's really true, Dan, if you would go to a typical bar back in those days, what was on tap?
Yuengling, Miller, Budweiser, and maybe a Sam Adams, maybe.
Maybe. But isn't that so funny to think it wasn't that long ago, right? That's what you find. And today, you wouldn't see any of those.
Now, if you order that, they dig it out of the bottom of the fridge that's covered in mildew.
Oh, yeah. But Carolina Brewery, on the other hand, like a microbrew does, only had their own brews, and the Copper Line was the one that I gravitated towards. And I think I know why, because as a young, naive beer drinker, I don't know about that, but very approachable. I actually remember the first time I ever had an IPA. I was like, what is this soapy, disgusting
garbage
thing? I couldn't stand it, but I found this Copper Line very drinkable, and really was the first microbrew that I ever got into.
It's a little sweet, very malty. I can't see it. It's in a can. I assume it's copper colored.
Yeah, it's a nice amber color. This is Copper Line Amber Ale, and comes in at a refreshing 5.2% ABV and 33 IBUs.
All right, well, thank you for the trip down memory lane, Josh. Cheers.
It makes me think, Dan, a nice amber ale like this, why did a beer like this not become the American standard beer? Why did it become this American lager, Budweiser? Because I could imagine sitting on a beach or by the pool with one of these, couldn't you?
Yeah, I think you can't water this down enough to make it economical and still taste all right. Because it's a pretty full flavor,
That's
I think,
true.
as a beer.
That'll be our experiment. We'll see. Can we
just
dilute
keep adding water to
10%? Can we dilute it 20%? See if it's still good. Anyway, Dan, I was excited to see this in the store. I don't think they had it in cans back in those days.
I'm sure they didn't. That's a new technology. Well, thank you for sharing it, Josh.
Sure thing.
All right, Josh, just a reminder that grad school is difficult, in case you forgot. And if you need help, some kind of technical support, Promega has a technical support team here for all of your random questions. You can find them online. You can call, you can chat, you can email them, and they will help you interpret your results and understand the steps of your protocol. So go to promega.com/PhD support whenever you need help.
Also, Dan, one more thing to be excited and thankful for. We have a new Patreon patron.
Who is it?
Wanted to give a shout out and a special thanks to Danielle, who joined our growing Patreon supporter family.
Excellent. I guess we'll see Danielle in the Slack channel for our Patreon patrons.
We sure will. And if you would like to join Danielle and become a supporter of the show, you can just go to patreon.com/HelloPhD, or you can go to our website, hellophd.com, and click the Become a Patron button. And you will help us purchase more of this delicious Copperline Amber Ale.
Can never get enough.
All right, Dan. Well, I alluded to the fact that I was already getting excited about this interview, so why don't we jump right into it?
All right, Josh, today we are welcoming Allison Paradise. She's the CEO and founder of My Green Lab.
My Green Lab. So is this like a St. Patrick's Day theme?
It's a St. Patrick's Day theme, yep.
It's an envious lab?
It
a
is.
Lab of jealousy?
It's a jealous lab. It's just devoted to jealousy in the lab and envy.
Yeah, so I guess we're going to talk a little bit today on how you can help make your lab a more sustainable and eco-friendly place.
Let's listen to the interview.
Hi, I'm Allison Paradise, the CEO of My Green Lab. My Green Lab is a 501c3 nonprofit based in the Bay Area, dedicated to building a culture of sustainability through science.
Well, welcome to Hello PhD, Allison.
Thank you. Thank you so much for having me.
And I want to give the audience a little bit of your background just to kind of establish your lab cred here. Correct me if I get any of this wrong, but you studied neuroscience at Brown and Harvard.
Yes.
You've been a research assistant, a research scientist, and you spent several years doing biological imaging consulting for Leica, which is a big microscope manufacturer that I'm sure everybody knows.
Mm-hmm. Yes, that's correct.
So I think it's safe to say you spent some time in and around laboratories. Is that true?
I think that's fair. Since the age of 17, that my first lab job was when I was 17. So I've been in the lab for a long time.
Okay. And so you're working on sustainability and the issues of lab sustainability now. At what point in your career did you say, hey, this is something that labs have a problem with and that I want to help with?
Well, actually, before that, I just want to back up and make sure I understand. When you say lab sustainability, do you mean like energy usage of labs?
That's part of it. So sustainability generally, I would say, has three main pillars, right? There's environmental, there's economic, and there's social. And most of our work has been focused on environmental sustainability, but that ties into economic and social sustainability as well. So we'll get into this, but our Green Lab certification actually touches on all these three main areas of sustainability. And then within environmental sustainability, that can be broken down further into energy, as you mentioned, water, waste, and then we call it green chemistry. So green chemistry really touches on energy, water, and waste, but we pull it out as a separate category in order to highlight the fact that people should be thinking about the chemicals and reagents that they're using in their experiments.
So you've worked in quite a few labs. At what point did you realize that there was a need to think about environmental sustainability for labs, that there was a special issue here?
The first day. The very first day I worked in a lab. As I mentioned, I started working in labs when I was in high school, and I had received an internship at Boehringer Ingelheim Pharmaceutical Company in Connecticut, where I grew up. And the very first day I arrived, and they had me doing a cloning experiment, which is immediately going to date me for anybody who's listening to this, because this was a legitimate experiment when I was working in the lab.
I wouldn't let an undergrad touch anything on the first day. As a high school student?
I know, it was
touch the glassware and the drying rack, maybe.
I don't know. Even that, I don't know. That's amazing.
They had a lot of confidence in us. I know. They gave me, basically they gave me blood samples, and they said, here's the protocol, have at it. And I just kind of figured it out as I went along.
There's a conversation for another day about safety training, but we won't.
Yeah, no wonder you thought about this on day one. You were like, what are they doing giving a 17-year-old a bunch of blood samples? This seems wrong. Yeah, just don't say the name of that lab on the air.
That's fine.
Yeah.
Okay. So you actually got to get your hands into an experiment you were cloning.
Yes, I was cloning, and I remember this very distinctly because there was the main area of the lab, and then they had sort of a back room to the lab where they had the tissue culture hood, and they put me back there. So I was by myself in this sort of extra bonus room next to the lab. And I spent the day doing the protocol. And every time, I went through boxes and boxes of pipette tips. So every time I used the tips for something that was touching PBS or water, anything that wasn't contaminated, I was putting them into a beaker so I could recycle them. And, I was stacking up all the pipette tip boxes next to the beaker. The day it finishes, I get to the end of the experiment and I'm about to go home, and I go up to the PI and I say to her, I have all of the boxes and the tips that haven't been contaminated, and I can't find the recycling bin. Where am I supposed to put these? And honestly, the look she gave me, I will never forget this look. It's just this mixture of disbelief, a little bit of disgust that I should be asking this question, a little bit of horror that I've wasted any amount of time separating tips out, right? And she just looks at me, she goes, "We don't recycle here. Everything is incinerated." And I said, "Wait, what?" But right, I'm
I just went through 12 pounds of plastic. Yeah.
Right. I'm like, why? Why would you do that? It doesn't make any sense. And she said, well, that's just what we do. And then I said, but, so you just burn it and that's the end of it? And she said, yes, as if I'm, she's so annoyed at this point that I'm continuing to ask questions about what is happening to this waste stream. And she said, you're going to have to throw all that in the trash and wash that beaker, and don't ever do that again. So it's a waste of time. It's a waste of glassware for you to be separating things out. And I left sort of stunned, because it never would have occurred to me that you wouldn't recycle things. I grew up in a household where we recycled aluminum cans and plastic, and I never would have said that we were an environmentally friendly household or eco-conscious or anything like that. My parents never talked about this sort of stuff. It was just something we did. And then to move into a space where I was generating so much waste over the course of a day, and I couldn't do anything but throw it into the trash for it to be burned, which was obviously going to be toxic in the air, was deeply disturbing. So I started taking them home.
Taking what home?
all of the pipette tip boxes.
Oh, the boxes, but not the actual used pipette.
Not the tips. No, not the tips. Those would have been a lot harder to smuggle out, but the boxes are relatively easy to smuggle out and
clean
put in
generally.
My parents. Exactly. So I would put them in my parents' recycling bin, and that started a tradition of me, every lab I worked in, taking home the pipette tip boxes, and then it moved into the Gibco bottles, and basically anything that I thought sensibly ought to be recyclable or be recycled, I would just take it home and recycle it in the municipal recycling.
Did your car start to fill up with garbage bags of glass bottles and No? No.
It wasn't like I think from a casual observer, I wasn't going off the deep end with this. It just made sense, right? I might have 5 or 6 boxes of pipette tips that I would go through in the course of a few days, and I would take them home with me and recycle them.
Well, what's interesting about this is, and I guess I've spent a lot of time in the lab too and around lab culture, and a few things strike me as kind of funny. And the first one is, I'm imagining, you as a 17 or 18-year-old confronting this biologist who says, well, of course we throw it all away and burn it into the environment. We're biologists. But then the second
Take that, environment.
Yeah. But the second thing is, and Dan and I, we sort of made a face of surprise towards each other thinking about you taking pipette boxes home to recycle on your own. But why wouldn't you? We recycle regularly as part of our normal household, and restaurants, we would scoff at them if they didn't have any recycling or events. But yet, for some reason, when you talk about doing it in the lab, it does seem
if you think about a pipette tip box is the cleanest thing on earth, right? It has been autoclaved. There's nothing cleaner than that pipette tip box. I put peanut butter jars in the trash that I can't quite get all the peanut butter out of, and that I put those in the recycle bin, and those get taken away.
Yeah, or like a PBS bottle. Right. Or
what did the recyclers ever give you feedback? Because I can imagine they're accustomed to seeing a peanut butter jar, but not a pipette tip box.
That's a good question. So at the time, no, nobody ever said anything. But now that I've been doing this for a few years, and I've had an occasion to actually speak with waste haulers and recycling centers, it turns out they would not have appreciated that. But the people who were taking the recycling bins away probably had not appreciated the fact that I had put those in there because they look like medical waste. So probably I was freaking them all out.
Oh
by
yeah,
putting
maybe a
this
red
in,
flag to
right?
see anything that looks like that. Yep.
Right. But I wouldn't have known that at the time because this is the bubble that you live in, right? When you're in the lab and in academia, you just don't think the next step that somebody else wouldn't know what those are or would associate them with a hospital.
Well, and what you're highlighting is I think it's an evolution that we go through in the lab. And I think, at 17, you walked in and said, this doesn't seem right to throw away all this plastic. I think we've all felt that way about different aspects of the lab. Why are we dumping this particular thing down the drain?
Right.
But you do, if somebody does it and then the second time you notice it a little bit less. And then after 30 years in the lab, you don't even get that twinge of, oh, maybe there's a better way to do this.
So well said.
So other than plastic waste, which I think is a huge issue that we can all see pretty visibly, are there other impacts, environmental impacts of labs, and maybe some that we don't notice that are important?
Yes, absolutely. And I didn't realize these myself until I started this work. When we first started the organization, it was focused on the visible waste. So plastic, gloves, for example, mercury bulbs, getting rid of mercury in the lab, just anything that was really obvious. And I attended a conference, I think about 2 weeks after the organization started. And I was listening to all of these people talk about energy consumption of laboratory buildings. And I was sitting in the audience. This is a great visual. I'm not a terribly large person, and I was given an extra large shirt to wear as a volunteer at this conference. So I'm wearing a shirt that really comes down to my knees. I look like a kid in her father's giant T-shirt. And I'm listening to all these people talk about lab buildings using 5 to 10 times more energy than office spaces, and that there's nothing that we can do about it because they're scientists and scientists are doing really important work and we don't want to disrupt that work. So rather than do anything about the energy consumption in these buildings, instead, we're going to focus our attention on the office spaces. And after listening to 3 or 4 presentations like this in the same session, I started thinking, this is ridiculous. The scientists would gladly do something if somebody just told them. I had no idea that the equipment and the space itself was using so much energy. If somebody had told me, I would have done something about it. So I raised my hand during the Q&A, and I just said, our nonprofit works in laboratory sustainability, and we address energy efficiency in laboratories. And at that moment, I had no idea about energy efficiency in laboratories.
Bold move.
I just figured, how hard could this possibly be, right?
Yeah, somebody should do it. Why not you?
Right. Exactly. And we were kind of already poised to be the people and the organization that would kind of bring all of this information into one place. So that's how I started learning about the energy consumption of labs, the water consumption of labs, which is enormous. And then thinking more, as I said at the beginning, about the chemistry, which is visible, but is kind of like you said, something that we just get used to, right? So you start and you're using something that you've had safety training on where they tell you, you can't inhale this, don't touch it with your bare skin, right? It's a known carcinogen. And you think, oh my gosh, I need to be really careful. But by year 10, you're sort of cavalier about it. Oh, I forgot my gloves. I don't have the goggles on, whatever, it's fine. So bringing that to people's attention, I think, is really important, and just reminding people that these are real things that we can change. They're really easy to change. We just have to think about them a little bit longer and shift our behavior a bit.
Yeah, the number of things that get dumped down the drain are astonishing. I mean, usually you'll bleach it first and then dump it down the drain, which I'm sure is helping, or not at all.
Not at all. No.
So I'm curious.
It's not good to be dumping that down the drain. Yes.
So I'm curious. It was really bold of you to to stand up in that environment and say, wait, well, maybe in the face of one option of not doing anything, maybe there are some things we could do. And obviously, you're very active in not just advocating for these changes, but trying to implement some of these changes. But do you ever run into opposition from scientists or others in science who are either skeptical that there's a problem or skeptical that anything can be done about it? And what do they say? And are there any, I guess, sacred cows of research that get in the way of some of your sustainability work?
That's a great question. Yeah, I think most people, if you talk about waste, it's relatively easy to get people on board with the idea that they should recycle. That one's a really easy entry point. But when you start talking about energy and water, it requires a behavior change paradigm shift that is not necessarily analogous to something that you would do in your house. So you brought up the point we recycle in the home, so obviously you'd recycle in the lab. But when you start to talk to people about turning off water baths, for example, that's a really great example because it's something people are very resistant to doing because it means in the morning the water bath is cold. And so you have to turn it on and wait for it to heat up. And that modicum of inconvenience is enough for some people to just say, I want nothing to do with this. It's too inconvenient. It's too difficult. What happens to the equipment? I've been told that I need to leave it running all the time or it will break. That's a really big misconception.
Which
that
equipment
has been
would that
perpetrated.
be? Do you have like a specific
everything.
example? Really?
Like everything.
I have to
yeah.
keep it running or it will break.
Or it'll break, right? So, I mean, there's some that you really should keep running, like HPLCs, anything that's under a vacuum. Like, you're not going to turn off a mass spec overnight. And not because it'll break, but just because it's a real pain to get it up and running and you lose the calibration. But for a lot of standard pieces of equipment, yeah, people think that if you turn them on and off a lot, that the equipment won't be able to handle it and they're more prone to breaking. And that's just not true. And I don't know where that idea came from. But it's something that we've inherited from generations before us.
So things like heat baths you mentioned, and heater blocks, incubators, things like that. It's got to be simple, like a little heating element. If there's nothing inside,
Well, I imagine those use a ton of energy. Heating elements.
Yeah.
I remember in my
cooling.
lab, we left the heat block. The water baths we absolutely left on, and
everything.
And even someone's like, "That's the 90-degree heat block, 90 Celsius."
Exactly.
Who knows how much
Exactly.
energy? Have you imagined how much energy
You're cooking eggs on it, yeah.
that one heat block used during the 5.5 years of my PhD? Right. Now I'm feeling extremely guilty.
I could do
about
that math
the
for
role.
you. I will find out.
Please,
Yeah.
please don't. My new thing, Allison, is tomorrow I'm going to start sneaking through the lab, switching off all the heat blocks. I'm just going to sneak through.
No,
Perfect.
I mean, I think there is a consideration here, which is research is expensive. And if you turn off something that needed to be on to get an experiment done, and I miss my time points, and it was a week-long experiment, that could cost thousands of dollars. So I don't think it's, there's no guerrilla tactic here. It has to be a planned and measured approach. But certainly there are activities that we can, steps we can take to make it better.
Mm-hmm. Yeah. I think when it comes to turning off equipment, what we usually suggest is putting things on outlet timers, because then it really mitigates this problem of, I thought that was going to be on when I came in the morning and now it's not. If you set something to turn off, say at 10 o'clock at night when most people are gone, and turn on at 5 o'clock in the morning before most people show up, you'll still save for those 7 hours and minimize the risk of, especially if it's got a heating element, that something might go wrong, that it might spark or burn out or something, catch fire in some way. And then it's also ready. So I think for me, outlet timers are such a great solution to that objection about turning things off.
Well, and think about that water bath again. The water bath, when it gets too low on water, we've all had it happen, and the element burns out. Or even grosser, the water bath is always full of whatever's growing in the water bath. We probably could use a few hours of cool down. Personally, I think.
So this is an interesting conversation, and again, you've sort of the outlet timer thing. You blew my mind, but it's such a
You are the most automated home person on earth.
That's
And
exactly.
maybe that's what's going to happen in labs. Every outlet in your house, you can tell Alexa to fix, right? To turn on and off.
Yeah, it's so funny. As soon as you said that, we were talking about the plastic recycling, and Dan's absolutely right. I got tired of my family, forgetting to turn the thermostat down during the day and forgetting to turn so and so light on or off, and so I have all of that automated at my house now. So during the winter, the heat goes down during the day, comes back up when we get home, goes back down overnight. The lights come on and off automatically. We don't even have to think about it, but we save a lot of energy. Why couldn't we do that in a lab setting? But yet, I'd never even considered it, but it makes so much sense.
Alexa, turn off tissue culture.
I
Right.
know, right? You should. You could buy Alexa, turn on the 37-degree water bath. Yeah,
Exactly.
that'd be great. So Allison, this is really great. We have probably a few thousand scientists who are going to hear you talking on this podcast. If we could convince them to implement, one or two of these little obvious tips and tricks in the lab tomorrow, what are some of these things? Are there any other things that they could do or should do that they could implement immediately?
Particularly if they're students or postdocs. I know that there's a lot of savings opportunity if you are doing procurement, if you're a PI, you're buying equipment. That's probably not where a lot of our listeners are, but what could they do tomorrow?
Good question. So I would say overarching, the best thing you could do for yourself and for sustainability in general is to just take a step back and ask yourself why you're doing things the way that you do them. So when you show up in the lab in the morning, I used to do a lot of tissue culture. So I would turn on the hood, I'd put my media in the water bath that had been on overnight, and then I'd leave and go do something else for hours. And then I'd come back and the hood has been on for hours for no reason, right? The media's been heating up in a water bath that was left on overnight. I would do what I had to do. I would do exactly what you said, Dan, throw things down the sink. And I never asked myself, why do I do it this way? So I think that simple question can then open up opportunities for you to see all sorts of other things that you could do. So that would be the overarching thing, I think. And then from there, some easy concrete things, aside from turning things off or putting them on outlet timers, things around with cold storage. So freezers use a tremendous amount of energy in laboratories. The -80 freezers, those use as much as a home every day. So they're
Every
about
day?
20 every day. They're about 20-ish kilowatt hours a day
Wow.
to run one of those. So anything you can do to help save energy there.
You're not saying
has
unplug those
huge
on a timer.
No,
Just to
no,
be
no.
clear to everyone.
No, don't unplug those. But
Eager grad
you
student
can-
tomorrow runs into the lab, puts an outlet timer on the -80 freezer. Oh, that would be a fun story for our next Halloween episode.
Okay, is there something we can do about that -80 freezer?
Yes. So there are the obvious things like keep them defrosted because that can really help make the freezer run more efficiently. Getting rid of samples that you don't need because that eliminates the need for buying more cold storage units.
But you can never read the labels after it's been in there for 5 minutes. So how do you know if you need it? I guess if you can't read the label, you don't need it, right?
Yeah, if you
Exactly.
yeah, I might need tubes 1, 2, 3, 4, and 5.
From 1977.
I think about this all the time, the tubes that I used to use even as an undergrad, about how poorly I had labeled them because I thought they're only for me. And now I think back and I'm like, oh my gosh, I'm sure those mice tails are sitting in a freezer somewhere. They must be, right? From mice that have been dead for over a decade.
Absolutely, yeah.
And I labeled with my initials ACP 1, 2, 3, 4, 5. Nobody's ever going to know what that is. So yeah, getting rid of those old samples can make a big difference. And then the last thing is a little bit around cold storage anyways, a bit more tricky, but is nevertheless worth, I think, having a conversation around. So when I first started working in the lab in that pharmaceutical company, all of those freezers were set to -70. In fact, I was taught to call them -70s when I was in high school. And then at some point as an undergrad, they became -80s and everybody started setting them to -80. Not every sample needs to be stored at -80. And in fact, I would argue that most samples are completely fine at -70. So looking at your samples and deciding whether they need to be stored at -80 or if they can be stored at -70 can have a huge impact. And the reason is because the freezer energy consumption is not linear. So if you set your freezer to -70, you can save 30 to 40% of that energy. And the compressor doesn't have to work as hard, which means the freezer is likely to last a lot longer, so less nightmarish stories about freezer failures. it just
We have
is
told
much
those stories
better.
before, yes.
Right, exactly, right? So it's overall just much better if you can do that. We have on our website a link to a Google Doc that we've been keeping of people who have been storing samples at -70. So you can see what they've been storing, how long they've stored it, and it has their contact information. So you can reach out to somebody else who's been storing a similar sample at that temperature and find out, how viable it's been, what they've been using it for, et cetera. So I would say that would be a huge, huge, huge thing that you can do.
Love that. Tap
And-
the scientific community to help
Exactly.
you improve your science.
You're jogging.
Exactly.
You're jogging my memory because I think now that I remember being an undergraduate in a microbiology lab where we deep froze a lot of our bacterial samples. I'm pretty sure it was a -70 that we had too.
I was waiting for you to say, I'm so old, it was -20 back then.
I remember when it was a -65.
We used to store ours boiling because it was so long ago.
Well, I mean, honestly, though, I imagine, and I'm finding this out just because in other realms of even in studying things like graduate admissions that have been done a certain way for a long period of time, at some point in the sciences, even though we like to think of ourselves as very logical and evidence
empirical, right?
We do a lot of things because we've always done them that way. And so, I mean, no one's probably done the experiment of, well, what if I store these samples at -60?
And they're totally
Right.
fine, probably.
Right?
Many of them, yeah.
You could continue walking that back, and there probably is a line, and we just go overboard. I want to ask one thing about this energy thing before
energy,
we go.
yep.
Yeah. Again, I'm thinking about the differences between our behaviors at home and our behaviors in the workplace, in the lab. And while part of, my personal desire to have an energy efficient home has to do with a desire to do good for the planet and my community, the cost of energy is directly paid by me. And so do you think part of this is because the way typical academic institutions are run, the cost of energy is not... PIs aren't directly billed based on the amount of energy consumed, but
they pay for the space, right? They pay
sort of
their
general,
grants.
whether
Yep.
it's almost like renting, right? Where the energy is
Right.
included, and whether you are energy efficient lab or you leave the freezer door open every day, you pay the same thing. So you've disassociated the cost with the amount of energy you use. Do you think that contributes at all?
Oh yeah, absolutely. 100%. It definitely does. And that's why a lot of PIs will give us a lot of pushback on this, saying, well, I don't pay for energy anyway. It doesn't matter. And my argument always is, well, you do pay for it. You pay for it in overhead costs. And if you don't want those overhead costs to keep increasing every year, then you might want to consider cutting down on the amount of energy you consume. Because if you're at a university in particular, all they're doing is just taking their energy bill and passing it along to you. And those rates keep increasing every year. So from that perspective, that's a really good way of actually making sure that you're not losing money. It's a bit more indirect, but...
Well, you're talking, though, about equipment costs, too. You're saying if I have only samples I need in my freezer, I don't need so many freezers. If I
Right.
can make the lifetime of the freezer last longer, I don't need to buy a new freezer as soon. So I think there's other money there.
Well,
Yes.
my power company, they often will incentivize things like buy like energy efficient bulbs. They'll sell them for really cheap or deep discounts on programmable thermostats. I wonder if something institutions could do, and maybe you've heard of some that have, is provide some financial incentives either through decreased overhead costs or something like that to labs that do take steps to being more energy efficient, because that's going to obviously cost the institution less in their own power consumption. And Dan, as you know, a lot of larger institutions produce their own energy. That's very
right.
costly.
A lot of universities do. Do you know of programs like that, Allison, anywhere where the labs get an incentive to do a better job?
Yes. So there are two types of programs. So one comes directly from utilities. So we did a bit of work with Energy Star and the Department of Energy to get Energy Star ratings for the -80 freezers. And so now quite a few states offer direct rebates for Energy Star -80s. So that is one route that you can go. The other is through the campus. And so I know actually almost every campus that has a program, a Green Labs program, that's modeled off of the work that we've been doing, almost all of them have some sort of incentive structure for energy efficient equipment. And sometimes you have to prove that it's energy efficient by metering the old equipment and the new equipment so they can give you the delta back. But almost all of them are open to incentivizing this because of the reasons you said. It benefits the campus. It helps with their energy bill, for over a long period of time. And also it just almost every university has some sort of carbon neutrality goal or something to reduce their carbon emissions. And this also counts towards that. So yes, if you are at a university, I would absolutely talk to your facilities people and just let them know if you're thinking about purchasing new equipment, say, look, we'd like to buy something that's energy efficient. What type of rebate would be available on the campus? And you can always also reach out to us. So we really do kind of bring everybody together. So if you're at a campus and they do have an incentive structure, we'll know about it and we can connect you with the right person, at least if you're in North America.
That's excellent. And we'll share in our show notes, we'll share some links and we'll let you tell people where to find you. I wanted to just quickly cover water and what you mentioned, green chemistry, because I think we've got people who listen who are in different forms of science. And so those might be bigger issues in different types of labs. Can you say something about water or toxic chemicals that everybody should just know?
Sure. So with regard to water, so we'll step away from a biology lab now and we'll go into a chemistry lab because chemistry labs can use a lot of water. There's something called single pass cooling that quite a few chemistry labs still use, and that's a way of cooling down a reaction by running cold water around it and then dumping that cold water down the drain.
Yeah, we did that in organic chemistry lab, I believe.
Yeah? Okay. So that's not really the smartest way to use water, right? So,
turns out.
So just using it once and dumping it down the drain is not ideal.
Don't drink it. We're not advocating that.
No. But if you can recirculate that water, that's a much better use of it. So we have been really advocating for eliminating this so-called single pass cooling. And a really simple solution is to put the reaction into an ice bucket with a fish pump. And that works really well
to circulate the water.
Yeah.
Fish
and then
probably don't like it very much.
If it's a tropical fish, you pay money to heat those up, you might as well get some dual usage, do some chemistry experiments at the same time.
Are you volunteering your fish, Josh?
Maybe PetSmart could get in on this. Yeah. Yeah. So what else about the green chemistry?
So green chemistry is a little bit more tricky because it really depends on the type of chemistry you're doing. Or the types of experiments you're doing. But I would say broadly about green chemistry is if you are not a chemist, this still applies to you. So green chemistry is not a subset of chemistry, right? It's not like you have organic, inorganic, and then green. It weaves through all types of chemistry and it applies to reagents as well. Some really high-level ones that I think are easy are if you're working in biology, ethidium bromide. Probably not a thing you need to be using anymore. There's plenty of other safer alternatives to ethidium bromide.
Go ahead, Dan. Give me credit.
Josh was just looking up ethidium bromide as he tried to understand what could be a good replacement in a green chemistry approach.
That first popped into my head. I'm a molecular biologist by training, and a lot of the people I work with are molecular biologists. And I know a lot of labs over the past few years have moved away from ethidium bromide to other alternatives that are less toxic to the researchers themselves, but I assume also less toxic to the environment.
That goes down the drain, doesn't it? I mean, you throw the gel into the biohazard waste, but then the buffer...
I thought that was green chemistry because it turns green eventually, and then you dump it down the drain. Not what we're talking about, right?
No. But yeah, ethidium bromide is a really good example. If you are in a chemistry lab, hexane is a really toxic chemical to be using. And in most cases, heptane can be used instead as a substitution. So that's a really simple, easy substitution to make that has a really big impact.
Those sound almost the same to me, but they're very different in terms of their toxicity in the environment or to people?
To people in particular, how they're metabolized. That extra carbon makes heptane a lot more difficult to break down into toxic byproducts in humans. Hexane is really toxic. So, and for all of those, there are actually quite a few guides. If you're interested, we have a really quick solvent selection guide on our website that's free. MIT has something called the Green Chemistry Wizard that's outstanding, where you can type in a chemical and it will tell you some other substitutions. Millipore Sigma, so formerly Sigma Aldrich, now Millipore Sigma, has on their website a really excellent green chemistry guide. All of those are really good resources. So if you have a protocol, and this gets back to what I said originally, right? If you have a protocol and you're looking at it with fresh eyes tomorrow, these are the types of things you want to start questioning. Why do I use methanol in this step, for example, right? Why am I using xylene? Why do I need 4% PFA in this particular example? Just asking those questions. And sometimes the answer will just be yes, right? It may just be that this is the right reagent, the right chemical that needs to be used in this particular protocol. And that's fine, because the goal is to do the experiment, right? You don't want to be substituting so many things out that you can't even get at the research question. And the same goes for everything else we talked about, right? You don't want to be compromising the equipment so that you can't do the experiment. But if you can look at it just from a slightly different perspective and just make sure that you're doing things as responsibly, as safely, as sustainably as possible, that has the greatest impact.
Well, and I'm thinking about some of our listeners. I'm thinking about when I was in the lab and, regularly doing fixation of samples for microscopy with 4% PFA. And, really, again, we are so tied to the way things have always been done because we feel like we just have to keep moving so quickly and we can't waste. We think of it as wasting any time. But really, if we think about it, maybe there's somebody listening who does something like this. You could take 1 or 2 days, try out using 2% PFA, see that it's just as good, and then maybe you've changed the way that lab does something else entirely, for years in the future, right? And just by taking a little bit of time once to just try out something that's more green and more sustainable.
Well, and I think that leads to the next question, which is, we have barely scratched the surface here, but hopefully we've gotten people thinking about the ways that their research is impacting the environment, and maybe they want to get involved. Is there any way that they can get involved with My Green Lab, or how do they take the next step to learn more?
Good question. So we have quite a few resources on our website, so you can absolutely feel free to look through the website. We have a certification program, which I think is a really good way of kind of diving into all of these things that we've talked about, including the waste and some of the other things I mentioned at the beginning, like the social responsibility, some of the economic sustainability. All of that is included in our certification. So I would encourage you, even if you don't want to go through the process of being certified, just to go through and answer the questions so you can see what the opportunities are. Is a really good way of educating yourself. We're always around as a resource. So our email is info@mygreenlab.org. You can always shoot us an email, and we are happy to help respond and answer questions. And as I said, there are more and more of these programs on campuses across the country. When we first started, there were maybe 10, probably not even 10 programs around the country like this that really focused on lab sustainability. And now there are over 100. So it's really growing, and you'd probably be surprised. There might be resources on your campus who could help with some of these questions, especially with the waste. So a lot of the questions we get initially are, this sounds great. I can do what I can do about energy, but I still have this waste stream. And that's something that has to be dealt with locally, right? We can't say universally, oh, you can recycle pipette tip boxes, for example, because not every waste hauler will take them, even though they ought to take them. So we can try to connect you with the right people in order to make it easier for you to implement some of the changes in the lab that you would want to implement. I think that's probably the best way to get involved, and is to start thinking about this, getting other students involved. We've had so many programs started by graduate students and even undergraduate students. It's so inspiring to see. There's a woman at Virginia Tech named Ellen Garcia, who I met at a conference. She got really excited about this, went back to her lab, made a whole bunch of changes, got her lab certified as a green lab, and now is starting to work through Virginia Tech to implement a whole Green Labs program on campus. And she's a graduate student. So it's incredible. And so, yeah, when you think about people saying, oh, I don't have time to think about this for 2 seconds. And then you look at this woman who's incredible. She's still doing her PhD. I think it's in biology. And so she's doing all of her lab work, but she's also just integrating all of these best practices into her work and then just sharing that with her colleagues. And there are countless examples of people like that around the country who just get inspired and go, you know what? I just don't want it to be like this anymore. And they just make a change.
Yeah,
so
that's awesome.
If that speaks to you, reach out to us and we'll connect you with other graduate students and we can start a network of people who are doing this.
I mean, I really do believe that scientists are a conscientious group. I think understanding science makes you curious about the natural world, and being curious about the natural world helps you to appreciate that we are having an impact on it. So we are a good group of people to go tackle this problem, and I'm really pleased that you're leading us down that path. Where can listeners find you online? Are you on social media? Will you be anywhere in the real world conferences that they might be able to meet you?
Yes, so we are on social media. We're on Twitter. We're on Facebook. We're on LinkedIn. Our website, of course, mygreenlab.org. And we do attend most of the major scientific meetings. So let's see, if you're a lab manager listening to this, we'll be at the Lab Manager Conference in May. We go to the American Chemical Society meeting. We usually have a booth there. The Society for Neuroscience, we usually have a booth. Cell Bio, usually every other year, we have a booth at Cell Bio. If you are a scientist listening to this and you think that this message would be well received by your peers at some conference that I haven't mentioned, let us know. We're always open to having a booth at these conferences. We usually do an interactive booth with questions relating to lab sustainability. It's a lot of fun. It's usually 10 questions. And if you get them all right, we give away T-shirts made of recycled plastic bottles that have our logo on them. And it's just a really fun way to get information about lab sustainability, kind of get introduced to the subject. We usually get thousands of people coming to our booths at these conferences. So yeah, if you attend any of these, please come stop by. And if you think of one that we haven't been at yet, let us know. And we also do present. So for example, I'll be in Oklahoma giving a presentation to graduate students there in April. The University of San Francisco, their Department of Biology is asking us to come and present. So we're going to be doing that. So we do big conferences and we do departmental meetings. Any place where we think the message needs to be heard, we are willing to come and deliver it.
Well, you sound like a very busy person. Thank you so much for taking the time and for spending it with us.
Thank you so much for having me. Are you kidding me? I love this. It's not a job. It's just what I get to do every day, and it's wonderful. And I really appreciate you letting me share this with everybody and with you. And thank you all so much for listening. I hope that this has inspired you to want to do something in your lab a little bit differently tomorrow.
Fantastic. Well, thank you so much, Allison.
Thank you.
Wow, Dan, my mind is just still reeling from that interview.
Why is it surprising to I feel it too, Josh. It is surprising to us that some of these things could be different than how they are, but why is it surprising? I think you alluded to it in the interview. We just get so entrenched in how it has always been done.
Yeah, some of the suggestions she had were so obvious and so not disruptive of the way things work, but could have a huge impact on energy usage and on the planet. I mean, if you think about how many labs are out there using water baths,
it's millions of square feet of space, and it's
like if you had to estimate,
so easy to make it better.
If you had to estimate how many, so we're recording this right now at 9:30 p.m. on what's today, Thursday night, across just America, how many heat blocks and water baths are sitting empty yet on right now in the laboratories across our great nation?
Okay, do you mean empty, or do you mean that guy left the one bottle of...
That's dried
that
up
was
3
me,
weeks
usually,
ago.
yeah. The MEM is still sitting there kind of growing something in the top.
But thousands.
Oh, tens of that, yeah, probably.
Yeah, I think of the energy usage for nothing, right? Nothing's getting done. Nothing's happening there.
It's just getting grosser as it sits there.
But just adding a simple timer on the outlet.
Which you had on your Christmas lights. You have it on your lamp when you go on vacation.
Dan, you saw it. I had Alexa controlling my Christmas tree this year.
Yeah. Totally revolutionary. Josh, you'll remember that 2 careers ago, I was doing energy efficiency and tracking for UNC Chapel Hill. And a lot of our focus was on the lab buildings because they really do use 5 or 6 times more energy than the average office building. And I don't think scientists really understand why that is. But I'll say it here just for the record. The air conditioning and heating system of a building has to obviously do a lot of work to make the air the right temperature and also do a lot of work to make the air the right humidity. So in the southeast where we are, you really have to cool down the air, which makes the moisture come out, and then you reheat that air with steam or with electricity. So you're doing this very energy-intensive process, which is okay, but in a laboratory, air quality matters, and we're working with chemicals, we're working with disease vectors. You have to change the air 22 times an hour or more. So it's something in that range. For a typical office building, maybe half a time, 2 times. I mean, it's a much lower number.
Wait, so I work in an office building on campus now, whereas I used to work in a research building. Are you saying that I'm breathing more stagnant air now than when I was in the... So I should spend as much time in the research buildings as I can to get better air.
No, I don't think it's necessarily better air. The air is changing so often because of all those toxic chemicals that your research is releasing. So anyway, the point is, the way to make that better is to keep your fume hoods closed. So if you're working in tissue culture or if you're working in a chemistry lab, keeping those fume hoods closed because the fume hood is pulling air out of the building. I think the last time I looked at the stats, it would cost $10,000 a year in energy just to run one vent hood like that.
And that shoots right up through the ceiling.
Straight up to the ceiling and
all
out the
those
top.
pipes on the top of the research buildings.
All the cooling that you did, all the heating that you did to that air goes right out the top. So there are things that you can do, but it is a health and safety concern, and I maybe there will be innovation to make those systems better. But right now, labs are very energy intensive.
Yeah, I want to actually circle back on one thing that you alluded to just a minute ago, because I think a lot of our listeners don't appreciate this. And I know I did not know this until you told me, but I have now told a lot of people this. So I remember working in the lab in the summertime, and it would be freezing cold. And people would be putting
icy.
on
You'd put
jackets
on a jacket,
or your lab coat to warm up. And, we would regularly complain and say, what a waste of money the facilities are costing the university, because they're keeping it so cold in here, colder than it's comfortable. They could warm it up 5 degrees and we would be more comfortable. But what you're saying is what actually has to happen is humidity is a concern. So you actually have to super cool the air much cooler than would be a comfortable room temperature, and then heat it back up. And so actually it's more energy efficient to keep it colder in the summer than if you did warm, you would have to warm it back up to 70 degrees versus 68 degrees. Is that what you're saying?
That's right. That is the approach that we take typically in the Southeast because the air is very humid. And it could be different in other places. And while I was at UNC, and this was quite a while ago, they were innovating that process so that they didn't always have to cool the air down so cold if the humidity was okay. So they were making advances, and I'm sure it's even better than it was. But yeah, to make sure that we're not growing mold inside the buildings, we've got to take the moisture out of the air. And to do that, you cool it off. But it's too cold to put into the building then, so you heat it back up with steam.
Yeah, very interesting. All right, Dan. Well, again, I thought this was a really illuminating interview with Allison, and I'm hopeful that we can actually have her back on the show in the future to talk a little bit about her career path, how she transitioned from being that wide-eyed high school researcher, spending her first day in lab, to now being CEO of this organization that actually is making some real changes with the way we run labs.
I'll bet there's a story there. We'll have to ask her back.
Yeah. And again, we would love to hear from you if this is something that sparks an interest in you or just ignites a passion, and you reach out to Green Labs or you institute some changes on your own campus or even in your own lab. Let us know that. Send us an email, podcast@hellophd.com. Send us a tweet at hellophd. We would love to share your stories about how you took some of the information you heard today on the show and made some real change for the good in your own lab.
So important. All it takes is one person coming up with one idea and then getting that idea out to other people. And I think that's how we make the change.
And you could change how your lab does things from now on, even after you leave.
Because it'll be the default. Yeah, it's the new standard.
Why do we use 2% PFA? Well, I don't know. It's in the protocol.
It's in the protocol. Just do it.
All right, Dan. Well, this has been a great show. I learned a lot, and I've been enjoying this Copperline Amber Ale. It takes me back down memory lane.
All right, Josh. Well, we will see you next time with some more hard-hitting, scientific something. What do we do here? I don't know.
Whatever we do here, we'll do it again next time. And if you have a question or a topic idea, we'd love to hear it. As I said, you can email us, podcast@hellophd.com, send us a tweet at hellophd, or you can leave us a message on our Facebook page. If you like the show, leave us a review on iTunes or wherever you get your podcasts. We certainly love the feedback. If you'd like to support the show, you can become a patron just like Danielle did. Simply go to our website, hellophd.com, click the Become a Patron button, or you can visit patreon.com/hellophd. We would love the beer money. Thanks to the ongoing support from all our patrons. All right, Dan, time to bundle up and head back into the frozen Arctic wasteland of North Carolina.
So cold, I can't handle it.
It's been so warm. I walked outside today, and I was like, why is it so cold today? I was like, it is January.
It is, yeah.
So,
we'll tolerate it for a little longer. And we'll see you next time, Josh.
see you next time.